Have you ever stopped for a moment and wondered how your phone can recognize your face in less than a second? No buttons, no passwords, no fingerprints. Just one simple thing you carry every single day: your face. Something so ordinary, so human. And yet, behind its simplicity lies one of the most advanced and rapidly evolving technologies in the world today: facial recognition. And today, we are going to go deep into it, not just to understand how it works, but to understand how it is quietly reshaping the way the world identifies us. Imagine standing in front of a camera. The camera doesn't just see you. It doesn't simply record an image like a normal camera. It analyzes. It maps. It transforms your face into data. Because in the eyes of a machine, a human face is not really a face anymore. It is a collection of numbers. The distance between your eyes, the shape of your cheekbones, the width of your nose, the contour of your jawline, the curve of your lips.
All of these features are converted into a mathematical representation called a face print. Just like fingerprints, no two face prints are exactly the same in the system's perspective. Even identical twins can often be distinguished by modern algorithms through subtle differences invisible to the human eye. But how does all of this actually work? Let's start from the beginning. When a camera captures a person's face, the first process is not recognition, it is detection. The system must first locate where the face actually is. In a crowded scene, filled with objects, motion, and light variations, the computer must decide which part of this image is a human face. This is where face detection algorithms come in. At this stage, the system relies on models trained on millions of facial images. It learns like a child learning to recognize patterns: two eyes, a nose in the center, a mouth below, a generally symmetrical structure. But unlike humans, computers do not see in the same way. They see pixels. Millions of tiny data points, each containing color and brightness information. From these pixel patterns, the system begins to search for structures that resemble a face. Once a face is detected, the next step begins. And this is where things become even more interesting. The detected face is then normalized. This means the image is adjusted so the face is aligned in a standard position. Even if you were tilted, looking away, or slightly smiling, the system tries to rotate and align your face digitally. The goal is simple: to make all faces comparable under the same conditions. After that comes the most important stage: feature extraction. At this point, the face is no longer treated as an image. Instead, it becomes a set of key points. The system maps dozens or even hundreds of landmarks on your face: around the eyes, at the tip of the nose, along the jawline, at the corners of the mouth, even subtle details like the distance between your eyebrows. All of these points are then converted into numbers, and those numbers become your digital identity. This is called a face embedding, a mathematical representation of who you are. Think of it like this. If a human face were a song, then the embedding would be its musical score. Not the sound itself, but the structured pattern that defines it. And the most powerful part is this: the system no longer needs the full image to recognize you. With just these numbers, a computer can compare your face against millions of others in a database in less than a second. But how does it know whether two faces belong to the same person? This is where mathematical distance comes into play. The system calculates how close two face prints are. If the distance is small, they are likely the same person. If it is large, they are different. Simple in concept, but extremely complex in computation. Because what is being compared is not just 2 or 3 points, but hundreds of dimensions of data at once. Behind all of this is a technology called machine learning and deep learning. The system is not manually programmed to recognize every face. Instead, it learns from data. The more data it receives, the smarter it becomes.
It learns from millions of faces, different ages, different expressions, different lighting conditions, different camera angles. From all of this, it builds an understanding of what a human face is. However, there is something many people do not realize. This technology is not perfect. It can make mistakes. It can be biased. For example, if training data is not diverse enough, the system may perform better on certain groups than others. This is one of the major challenges in modern facial recognition systems, because even though it appears neutral, it is heavily dependent on the data it learns from. Now let's go deeper into real-world usage. You probably use facial recognition every day without even noticing. When unlocking your phone, when entering a secure building, when passing through airport security systems, when surveillance cameras identify individuals in public spaces, even on social media where photos automatically tag your friends. All of this is powered by facial recognition technology. Behind the scenes, the process is always the same. Detection, normalization, feature extraction, comparison, and decision-making. But what makes it feel almost magical is its speed. In less than a second, the system can decide whether you are allowed access or not. But let's pause and think about something deeper. If a machine can recognize us just by our faces, what does identity mean in the digital age? Is a face still something personal? Or has it become data that can be stored, analyzed, and tracked? Because in more advanced systems, facial recognition is not only used for unlocking devices, it is also used to track individuals in public spaces. Connected cameras can follow a person from one location to another without them knowing, without any direct interaction. On one hand, this provides incredible security benefits. Criminals can be identified more easily. Missing persons can be found faster. Access to secure locations becomes safer. But on the other hand, it raises serious questions about privacy. How far should technology be allowed to see us? And who controls our facial data? Because unlike a password, a face cannot be changed. You cannot reset your identity like a password. This is why facial data is considered one of the most sensitive forms of biometric information in the digital world. Now, let's go back to the technical side. Modern facial recognition systems do not rely only on static images. They also analyze video. This is known as facial recognition in motion. Instead of a single image, the system processes multiple frames per second. It studies subtle changes in expression, eye movement, head orientation, even walking patterns. All of this increases accuracy. At more advanced levels, the technology can even detect liveness. Is the face real and present? Or is it a photo? Or even a mask? This is called liveness detection. The system may ask a user to blink, turn their head, or follow a specific movement, all to ensure that the subject is a real human being and not a fake representation. But development does not stop there. In some high-security systems, facial recognition is combined with artificial intelligence that can attempt to predict behavior. Not just identifying who you are, but estimating what you might do next. Of course, this is still an area of ongoing research in many parts of the world. But the direction is clear. Deeper, more personal, and more complex systems. Now, imagine the world a few years from now, where cameras are not only in phones or buildings, but everywhere. On streets, in shops, in vehicles, in public spaces. And every passing face is instantly recognized in milliseconds. A world like that is no longer science fiction. It is slowly becoming reality. But like all powerful technologies in human history, facial recognition is not something that can be seen in black and white. It is not purely good, and it is not purely bad. It is a tool. And like all tools, its impact depends on who uses it and for what purpose. In the right hands, it can save lives. In the wrong hands, it can violate the privacy of millions. And in the middle of all this, we as humans are in a unique position. We live in an era where our face is not only our social identity, but also our digital identity. Every time we smile at a camera, we are not just being photographed, we are being translated into data. And perhaps without realizing it, we are becoming part of a system far larger than we can see. A system that keeps learning, keeps evolving, and keeps recognizing us even when we are not paying attention. In the end, facial recognition technology is not just about machines recognizing humans. It is about how humans choose to be recognized by technology. And maybe the most important question is not how does it work, but rather, how far do we want it to understand us?